Hi again. In our last two videos, we looked at prime factorization with factor trees, then we looked at greatest common factors and least common multiples. In this third video on this subject, we're going to look at how can we use the greatest common factor to help us when we are reducing or simplifying our fractions. Let's look at if we had 72 140ths. Those are not numbers that we normally would be able to tell right away what is my greatest common factor. So if we went and looked at a factor tree for both of those numbers, and we might remember that 72 we could say was 8 times 9, 8 was 4 times 2, 2 was prime, 9 is 3 times 3, both 3's are prime, 4 is 2 times 2. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. That was a number that we used previously. For 140, you might look and say, well, I know that's 10 times 14, and 10 can be broken down into 2 times 5, both of which are prime, and 14 is 2 times 7. Again, both of those are prime. So when if we were looking at the prime factorization of 140, we would write down 2, 5, 2, and 7. But remember, I told you in our last video that it's very important when you're writing down your factors, especially when you're finding the least common multiple or the greatest common factor, you need to line them up if they have something that corresponds to it. So there's a 2 here and there's a 2 here. I'm just going to put a check in that so I remember I've already written that one. Then I have a 5. And I check here, is there a 5? No, so I'm going to write it over here. I have another 2. Since I happen to have another 2 here, I can put another one down. And then 7 would go over this way. So when I'm looking at reducing 72 140ths, what I want to do is find out what is the greatest common factor of both 72 and 140. You might remember from our last video, we looked to see which numbers they have in common, and it would be 2 2's, and 2 times 2 is 4. So what I'm really doing is I'm going to divide both my numerator, 72, and my denominator, 140, divided by 4. The reason I can do that and have an equivalent fraction, if you'll remember from the other video, so we're really dividing by the number 1. 4/4 is 1, and any number divided by 1 equals that same number. Now, the way we can use our greatest common factors and our factors, prime factorization, is really kind of neat because a lot of kids get confused sometimes with the division, or they don't like doing division, they would much rather multiply. Here you can use this information to figure out what 72 divided by 4 is, because really if we divide out 4, just cross those out because 2 times 2 is 4. I've just divided that by 4. My resulting answer is 2 times 3 times 3, which is 2 times 3 is 6, and 6 times 3 is 18. So my new numerator is 18. If I use that same idea for 140, remember we divided out the 2's, I have to divide out the same thing on the top as I would on the bottom, and they have to be the only common factors. But when I do that, I just have 5 times 7, which is 35. So 72 over 140 can be reduced to 18 over 35. Let's look at another one just to make sure that you understand that. If we were looking at 15/45, some of you might look right away and say, oh, I know they're both divisible by 5, and you might try dividing the 5 out, and you might say, well, I'm going to divide this by 5/5, and I get 3/9, and you might think you're done, but you really wouldn't be, and let me show you how finding The numbers with a factor tree can really help you with that so you don't make that mistake. We know 15 is 3 times 5, and both of those are prime numbers. And 45, you might say, well, that's 5 times 9. 5 is prime, 9 is not. 9 is 3 times 3. So if I was writing down the factors, the prime factors for 15 and 45, 15 I would write 3 times 5. 45, I have 5, 3, and I have another 3. I'm just going to put that over here. So I really should have divided this. Let me move this down here so you can see. I should have looked and noticed that it's divisible by both 3 and 5, and 15 is my greatest common factor. So I'm really dividing by 15 fifteenths. Notice if I go back up here, get rid of that, I don't have anything left. It's not 0, it's 1, because any number times 1 equals that same number. And I get rid of the 3 and the 5 for 45, and I have 1/3. So 15 45ths is really 1/3. I'd like you to try working on some of the reducing fractions worksheet. You can use whatever method works for you. I like to show you a variety of ways because everyone's brains work a little bit differently and people see things in different ways. So use what works best for you. If you have any questions, please ask me on the forum post and I'll be happy to answer them, or you can wait until our next live class to ask any questions. I hope this made sense to you and that you've enjoyed learning a little bit more about how to use factor trees to make doing fractions so much easier. Have a good night.